Hey, welcome back to Arts Astro. Today we're going to have a quick look at doing some image processing, but without PixInsight. So everything we're going to do is all free tools. I'm going to go through the entire process and we'll see how we get on. I have done this one before, but it's in this set of images, but we will see how we get on. So first of all, what we need to have is our actual images. So we've got all of our light frames we've taken. These are 125 2-minute exposures of the Galaxy M33, so hopefully this will come out quite well. We've also got some flat frames, calibration frames, and some biases as well. I did also take some dark flats as well, and I think I took some dark somewhere as well, but I've managed to stack this together without those and just with biases and flats and lights, so we'll see how we get on. It's a very strange process I've gone through to image these, so let's have a look. So first of all, what we want to do is we want to sort out what's good and what's not good from these. And if you're anything like me, sitting through and looking at 125 pictures, trying to work out what's good and what's not, a lot of time. So we go into ASTAP, as I call it, ASTAP. It's the astrometric stacking program, and we going to stack, make sure we're on lights, click on browse and find our lights folder, and we want to select all of those and press open. So these are all our light frames. Now the other thing that I really want to use ASTAP for is to analyse them. Are they any good? Are they okay? Do I want to use them? Do I not want to use them? It's really quick and dirty, but it worked for me, so I'm not going to argue with it. So all we do is click on Analyse and Organise Image, and it will rotate through every single image, measure the background in it, measure the number of stars in it, gives it a quality value, star quality value kind of thing. The HFD is the half width, full width half thing. I can't remember the thing for it, but anyway, and it just literally goes through every single frame, gives them a measure. You can see I've got untick worst frames image, untick worst images. So what it does is any images which it thinks is bad, it will just untick. So what we can do is, if we sort by quality, you've got the best one at the bottom, and scroll all the way up to the top. We've got all the ones that it thinks is no good, which is excellent. So I mean, if you want to look at one of those bad frames and see why it thinks it's no good, we can open one up. That one it has determined is no good. It's probably because it's quite bright. Yeah, background's 1370. This one's probably full of clouds. Yeah. This one, as you can see, I had an issue when the mount wasn't tracking 100% right, so we got star trails in it. Similar on that one. Not sure what's wrong with that one, but it thinks it's bad, so that's good enough for me. And then if we have a look at what some of the good ones look like, yeah, that's a lot better. Looks a lot clearer. Right, so what we're going to do here is we're going to highlight and select all the bad ones and just right click and rename them to back files. So that leaves us with 110 good images that we can use. So all we can do now is close that. We don't need ASTAP anymore, so we can close it completely actually, because we don't need that anymore. And then we move into SIRIL. Now I've tried stacking these before in Deep Sky Stacker, but for some strange reason, there's a gradient in these images. I think it's to do with light pollution. So there's on one side of the image, there's a gradient which runs from one side across. So trying to get that out, after stacking in deep sky stacker, it just wouldn't work. I don't know why. It just, every time I ran it through Graxpert, it would take out the gradient, but then it'd take out half the image of the bit we want, so it's no good. So what we're going to do is we are going to see, we've already got the home folder selected to where our project is, and that folder, which is this one here, has got to have these folder names in with the appropriate files in. So biases, flats and lights. The default script in SIRIL is this one, which needs darks as well. If it hasn't got darks, the script fails and it won't do it. So the other thing we're going to do is we've downloaded a different script called OSC pre-processing without dark. That works fine. So if we click on that, yep, run script, absolutely fine, and let it run. Now this pre-season one's pretty fast, so it shouldn't take a long time to splurge through these, but I'll probably speed it up if it starts taking a minute or two. Let's see how it gets on. Okay, I'll skip forward on this bit and I'll come back once it's finished stacking. So there you go, finished. Not that long at all. Okay, so we're thinking, well, okay, script's finished, but there's nothing on screen. Well, that's fine. All we need to do is open the result. So this result.fit is the result of the stacking. There's a process folder where it does some processing, but we're not really bothered about that. So get our result.fit, open it up, and there you go, there's our completed stack. Now for the uninitiated, they may look at this and think, oh, that's a bit underwhelming, and it is, but so what we're going to do is going to tease some data out of it, because there's a process called stretching, but there's some other bits and pieces we want to do first. So first of all, the colour balance is completely wrong. By default on the camera, the colour balance is just set for all the same, red, green and blue, all the same values. I think by default it comes in at 128 on the setting, and it's between 0 and 512, and I think I set these as a test to 255. Seems to work. Not sure if it's the right thing to do or not, but it is what it is. So if we go to image processing and colour calibration, and this is a pretty good tool. I mean, remember, SIRIL and everything's free, so what photometric colour calibration will do, it will plate solve the image, i.e. it will look at the picture, think, whereabouts am I in the sky, find it, and then correct the colour for what has been recorded previously. And it's literally a one click kind of thing. So we hit photometric colour calibration, the details of where the image actually is already stored within the Pics file, which is really handy. It knows what our focal length for its telescope is, and we knows what the pixel size for its telescope is. The only thing we have to hit, click OK, boom, there we go, changed. So that colour balance looks better. The night sky actually does look black rather than blue. So we can close that. So now what we need to do is, there's probably a hell of a lot of noise in this, and the gradient will be there. You probably can't see it at the minute. If I stretched it, you could. In fact, if I auto stretch it, yeah, you can see the gradient on the left, up here on the left, and it moves. It's just a gradient that runs all the way across, and it seems to be the light pollution. But you can see from just by clicking the auto stretch button, you can see what we're going to pull out of it. It's quite impressive, I think, even for the telescope I'm using, and the collimation's out, and all sorts. So that's all to come in the future of getting better with these things. But let's carry on with this. So let's pull it back to linear. What we're going to do is I save everything in stages. So we've got as a result. So what we want to do, we'll call this M33 because that's what it's going to be, and we're going to save it as a fit file. And we're going to save 32-bit flying bits, hit save. So we now come into a tool called Graxpert. It's very, very quick, this program, as long as you've got a decent PC. If you haven't got a decent PC, it's slow at doing the noise reduction, but this PC is pretty quick, so it's not too bad. So we will find that image. So let's find our M33 fit. Open that up. See at the bottom we've got it displays it with a stretch, but you don't have to. It won't save it with a stretch unless you ask it to. So I think that image is looking pretty impressive already, to be honest. But let's see what we can do now. First of all, do we have to crop it? In all the previous software, I think we should give it a little crop on this side. It's not quite uniform and right at the very edge, so you might just have to want to take that edge off of it. So what we will do is we will hit the crop button, gives us a little crop pixel. We don't need to take a lot off, but it's just the very edge. So move like that, move that in a little bit like that. There we go. And apply crop. Bang. So all we're doing is just taking the edge off, because when we're taking lots and lots of pictures, you're never going to get 100% fully square on every single picture. In fact, what I should be doing is something called dithering, so that in between a number of images, the scope would move ever so slightly, so it's just a very slightly different spot. Take more, it helps get rid of noise, and there's a lot of noise in this image. I don't know if you can see it in the video, but all this garbled stuff here, it's just noise in the image, and it's just a pain. So anyway, so first thing we're going to do is we are going to do a background extraction. So we configured for a method, no smoothing on it, calculate, just hit the calculate background button. What's it come back with? Excellent, that doesn't look bad to me at all. What we will do though is have a look at the background and see what it's removed. And the main thing that it hasn't removed is all around the centre. In fact, can I show you a previous one? Let's see if I can show you the issue I was having with Deep Sky Stacker, because I'm assuming it will still come up the same. Remember where I put the files. No, that's the SIRIL version of them, so where are they? As you can see, I've been through this many times trying to figure this out. So this is the stacked version that comes out of Deep Sky Stacker. So it's the exact same data, just one's gone through Deep Sky Stacker, the other version's come through here. So let's see if we have the same issue. Again, we'll just take off the edges just to make sure it's not picking up anything on the edge. Apply that crop, background extraction. There. So you see, it's lost a lot of the information in the middle for some reason. Really strange. And if you click on the background, you can see that in the middle, this is where it's taken all of the. It tried to take a gradient out of something that doesn't want a gradient taken out of it. So I don't like that at all. For some reason, stacking it in SIRIL seems a lot better. So let's quickly drop back to that. Make sure I got the right folder. There we go. M33 open. So back to this. We are going to again just quickly go through the crop. just like so. Must remember to hit apply, otherwise it doesn't apply it, and then you look silly. Okay, let's apply the crop, background instructions. Much better, much better. So there's the background, and again, it's not removed it all from the centre. I don't know why Deep Sky Stacker does it like that. It's probably my data more than anything, to be honest, but anyway. So, done a background extraction, quick denoise, strength 0.9 should be fine. Hit denoise, let that rip. This won't take long on my machine. I mean, I'm only rocking a 3070 for the graphics card, but it's enough for this. Run this on a 4-core laptop, might take half an hour. Run it in this with a graphics card, and the hardware acceleration enabled, doesn't take long at all. Nearly there. It's making me out to be a liar now, isn't it? Just see if it's... So sometimes with Graxpert it plays up a little bit. It's very rare that it does it. Let's just get this back into view again so you can see what's happening. It might not like this. In fact, I'm using a ultra wide monitor, so it can be a bit finicky. And as you can see, I'm recording on this very left hand edge. You can see the remnants of OBS that I'm using to record it, but because I've got the screen set out in 16:9 on one half of it, and then I've got this little bit of an edge here, which is just where the OBS is. Anyway, it's fairly quick anyway, so let's try that again. Load the image back up. Quickly do a crop, just to take the edges off. Apply background extraction, calculate. Excellent. Quick look at the background. Looks fine. Into denoise. Try again with the denoise. Fingers crossed. Fingers crossed it just works this time. Hey, there we go. So we can see that a lot of that noise has disappeared from the background on both sides. The gradient's now being removed. Excellent. If you want to take a look, that was the original. That's what it looked like when it was gradient corrected. That's what it's like when it's denoised. That's all I have to do. That's all we needed for Graxpert. Very, very quick. Save the process. It automatically puts a Graxpert on the end of it. Absolutely fine with that. There we go, saved that. So then we can go back into SIRIL. If we open that up, Graxpert, open, there's his image. We can auto stretch it. Still doesn't look terrible. So what we can do now is we need to, I think we need to give it a bit of a stretch properly. So I use generalized hyperbolic stretch transformations. It's a bit of a dark art for some people. I don't do a lot, as in tinkering with the numbers. The other thing I do is for the symmetry point where the line intersects with our data. There's our data here. Normally you'd see it like this, it's all pinned across to the left, and the idea you want to stretch it out, literally stretch it out, and bring the data into the middle. So we can use that to zoom in a little bit. We can see where we want to put the symmetry point. I normally put on the leading edge of the data, and then we just need to slide it across. And as we slide it across, see the image gets brighter and brighter and brighter. And we just want to put it somewhere reasonable. I think that's not too bad. Maybe a little bit more. Yeah, about there. You can always come back in and add some more to it, or take a bit off, because basically you click apply, then it resets everything, and then you can do the same thing again. But what we're going to do now is, because everything's now going a bit grey, what we want to do is to shift the black point. So now we've stretched the image data out, we want to shift it all linearly. Yeah, we want to shift it all over to the left to get rid of the black side of it. So we change from generalized hyperbolic transform to linear stretch black point shift, and you can just click on the numbers, click on the plus to shift it across. Use the slide as well, of course. But the thing we want to look at is at the bottom here you've got this thing called clip. Now if there's any data, any part of the image that we move too far to the left, so any dark spots we move too far to the left, what will happen is you'd lose in that data effectively. So whenever this is at 0, you are not losing absolutely anything, and you're just making your dark point darker and darker and darker and darker, and you can see we can get it. We can put it right up next to. Probably going to go a little bit further. You'll see you see there. So there we're losing data. At that point we're losing data, and as we carry on and carry on and carry on, you see that the screen is starting to lose bits of it. We don't want that. We've lost like 35% of the data there. We don't want to do that either. So what we just want to do is get as far left as we can, so the background looks nice and dark. But at the same time, we try not. I mean, a little bit. It's not bad. It's fine to lose, but you don't want to be losing full percentage points. 0.1% probably be all right. But that looks fairly good. I'm going to flip the image upside down because I see it that way in all the other images I've done, and I think it looks better that way. So why not? Okay, so now what we want to do, in fact, let me just see if we can give it a little bit more of a stretch. There is another thing you can do, which I have done before, is if you go back to generalized hyperbolic transform, you can do a thing called, you look at the logarithmic scale. And I try and find there's a little hump in the middle. I can't remember, I saw a video of somebody doing this and they were describing this hump. And then as you adjust the stretch factor, it's just popping the middle out just that little bit more. Not too much, but just a little bit. think that looks okay. So apply that, close that. It's no bad image, is it really, so far? Pretty good. So the problems with the flares on the stars, that's my telescope, it needs some work and some collimation, but overall that's not too bad. So, what we're going to do, what can we do? So, in PixInsight you've got something called Blur Exterminator. I can't realise I'm looking over here and not looking there at the camera, so apologies everybody. So what we're going to do is, there's some software and it only came out about a week ago, 2 weeks ago maximum, at the point of making this video. So what we're going to do, we have to save it. Up until now we've saved everything in a format called FITS. And what we're going to do now is save it in a format that is a TIFF. So we're going to put it into this software called Cosmic Clarity, Sharpen and Denoise. It's excellent software. The results are crazy. So we're going to save the file as a TIFF. Hit save. 32-bit floating point. Make sure the ICC profile data is embedded. Hit save. And then if we drop into the software, so what we've done, we've put our file in here. It's not an installable software. It's basically you download a zip and extract it, put it somewhere you want it. You get two executables. You've got Clarity and Denoise. You only run one at a time, essentially, but you put the image you want in to run the software across in the input folder, and it'll spit it out in the output folder once it's done. So let's run Cosmic Clarity. So do you want to use GPU? Yes we do, because it makes it really fast. We want both because we're doing stars and galaxies, so star and the galaxy, so we definitely want to be sharpening both things. Still a sharpening amount. So far I've left this at 0.9. It seems to work pretty well at that. And non-stellar sharpening, I normally put it about 4. Obviously if you get the software have a plane, you know, it's dealer's choice on which options you use and values you use, and if you like the image or not. And then just say OK, and it will churn away through the image. Excellent. So what we can do is, if we move the input into this stage, as you can see I've been playing around with this quite a bit and a couple of other things, and then we can look at the outputs. This is our output. I'm not going to load it yet, because what I'm going to do is I'm going to take a copy of that, put it back into the input. So we've just sharpened it. So let's run a denoise over it. Now, we've already run a denoise in Graxpert, and it looks pretty good already. We've run a sharpening. At this stage, what we're going to do effectively is take two copies. We're going to take one sharpened and one denoised, and we're going to look at which one we think's better. The denoise, I think I've run it before, and it removes some of the galaxy nebula. So just running the sharpening seems to be enough, but we'll run both anyway, just so we can see and have a look at the end. So do you want to use GPU acceleration? Again, yes we do. Denoise strength 9. Yes, thank you very much. And yes, full denoise. And let it rip. And what it does, it will separate the channels, and then it will run the denoise on each individual channel. So there we go. So in the output now we should have two files. We've got one sharpened and one sharpened and denoised. So if we go back to SIRIL, this is before sharpening. Click open, find our forget the right folder, find our output folder. So let's start with the sharpened. So this is the before, that's the after. It's just that blows my mind, that software. It really does. It just makes everything pop. So I mean, to me, the only thing missing from this image is a bit of colour now, because it just looks a bit grey. So how are we going to do that? Well, all we're going to do is go into colour saturation and play around with it, see what we get, see what looks good. Give it to the background one. That looks pretty good there. Colour saturation again. Not too much. So they've got stars coming out, nice colours now, nice blue star up here. Lots of colour in the galaxy itself. Still got a lot of the nebulosity in it. All looks pretty good to me. So for that image, I think that's pretty much it. So we'll save a version of that in here. So we'll call that back to a Pics file, just in case we need to go into it and do anything. We'll also save a version of it into our folder as a JPEG, so we can see, we can just load that up, and then we were going to have a look at the other version, weren't we? So if we go to denoise output, and this one's the denoised version. So to me, that's just this. Yeah, somebody pointed this out to me on Stargazer's Lounge, that it just, there's a bit of the nebulosity lost on the second denoise, and it's like if the image doesn't warrant the denoise, then does it really need it? But all we can do is the same thing again, colour calibration, spice up the colours a bit, and again it's just a feel thing, or what you think looks pretty and doesn't look pretty. Probably a bit too much that there. There we go. So again, same thing again. I'm going to save it as a Pics file, just in case we do want to come in and tweak it and play around with it. And that's saved in our M33 folder. Again, we'll save it as 30-bit floating point. And then we also just want to quickly save it as a JPEG. Oops, I don't want to put it there, do we? Try that again. JPG. Save. Save again. And that's it. That's how we quickly, very quickly, edit some processor a picture we've taken. So just get this in the right place so you can see it. So can we swap between those? So this is the sharpened and denoised, and that's just the sharpened. I think I prefer just the sharpened, to be honest. Yeah, I think what's happened is the denoise puts the grey back in, and I think on the previous time I've done this, I've then dragged the black point back down again. In fact, we've still got it open in SIRIL, so we can look at what the black point's doing. Take the logarithmic off, look at the black point shift. Yeah, let's see it there. So let's drag that black point down. As you can see, when we start to drag the black point down, we're starting to lose some of the data on the bottom. We don't really want to do that. Let's take it to 0.1-ish and apply that, and then let's overwrite the ones we've already done. So we want to save that as a fit. Sharpen denoised, yes. Replace, save, and then let's also save it as the JPEG. Just make sure we've got that. Which one are we in? We're in the denoised. We're going to overwrite that, so let's come out of that one. Replace the JPEG, save, go into the image. So it's that one line now. Where's the sliding on there? It is. Yeah, see, it's still gone a bit greyer. I think I do prefer this one. But look at that. How good is that? So hopefully I'm going to be able to fix things like, so what, I think the collimation is out on my telescope to a point where the secondary mirror was a little bit too far down, and so the stars over on this side are pointing at the screen, so if you can see it. Stars over on this side are a bit more in focus, whereas you can see the stars on this side aren't. And in fact, there's a tool inside SIRIL that if you click on the hamburger menu, as it's called, you can go to image information, dynamic PSF, and there's a button here which will show you how much tilt is in the image, and there is a lot in this one. So I'm hoping that the adjustment and recollimation that I made yesterday is going to be better and sort that, but we will come to it. So anyway, that's how I process an image without PixInsight. Unfortunately, there is a lot of dropping in and out of different software. ASTAP, quickly cycle through the images, make sure that we grab the ones we want to use. SIRIL, just to create the colour balance. Take that back out, put it in Graxpert to get rid of the gradient, and do a denoise. Load it back into SIRIL again. Do an initial stretch, make sure we've got stretch of data out, something which looks like something we can work with. Drop it into cosmic clarity, run a sharpening on it, which is very similar to what Blur Exterminator is in PixInsight, which everyone really raves about. I haven't got PixInsight, I have no idea. And then back into SIRIL again, just to add some colour. I'm sure there's a million other things you could do with some of the bits in the software, but as a quick, let's make something pretty, I think that's pretty good. Right, that's me for today, and I'll sign off, and thanks for watching. If you enjoy what you've seen, there's more to come. Please like, subscribe, do all the bits that YouTube does, and we'll see you in the next one.